teams there, no? Doing the thesis. Okay, that needs this one, no? Because group of Anna Faith, Yuka, and Aliyah, who else? And the others, I've noticed, no? Okay, I discussed this to them, no? These ones. Again, no? Please, can you see your screen? Because this will be my last days for these ones, no? I need to actually discuss this parallel to your e-survey before we survey next week. Okay, sige. Sino ang hindi pa nakakita nito? Nasa thesis ito, ha? Ayan po ay nasa thesis. I think sila Pagarigan, no? Si sino bang kapatid ni Ashley? Si John Rain. Okay? Okay, sige. So ito yan, no? Ito yan, yung open ko. Again, I need to discuss this, no? So that you can check again your e-survey questions. Okay. Para ma-polish na siya, no? Kasi diniscuss ko na ito dun sa mga alos patapos na. Sila Yuka nga nagtatanong sa akin kung pwede na mag-survey. But then again, no, we are waiting for that last lesson. It is the hypothesis of correlation. Hypothesis testing of correlation. And then, later on, no, I'll give you, sige, ito na yung mga yan, no, mga nag-a-ask ng meeting sa akin. Sino pang isa? Libutan ko na. Okay. Sila Villarino yata. At saka nung sila Montefalcon at sila Zyrene. Okay, sige. After, no? After an hour after your math, take a break 1 hour, then 1:30, no? Okay, the same meeting. Para ma-discuss ko na to at wala na akong alalahanin, no? We need this. I even discussed these recommendations, how to do with those ones, no? For the others. Okay, and then afterwards, after discussing this, and then I have to actually parang spot check lang, no? Spot check on how you created your e-survey based on the research questions and the statement of problems and or scope, no? And limitation. Sige, let's go. Okay. So for this one now, no? What is the relationship? Okay, it says there, no? If this is your guide actually, no? In doing your e-survey, then there is but question there. What is the relationship between X and Y? Okay, so we're talking about the variables X and Y. We do not know what that is in your thesis, right? Okay, X and Y, no? Do they have strong relationship, blah, blah, blah. And then what have we actually discussed about this one, or what is the statistical method that we have here, including the degree of relationship that we studied? How do you actually measure it? Of course, yung correlation, no? Correlation coefficient. Nakuha? Ayan. Okay. And regression, pareho lang naman yan. No? Picture lang naman yung regression. Okay, sige. Ayan siya. What is the relationship? Dapat meron po kayong ganon, ha? Okay. Like you are actually, for instance, your thesis is, this is the title, and then you ought to know, no? That there might be a factor for that title. Ano bang problema ng factor? What is the problem of that thesis of yours? If that is a problem, of course, there might be factors. What are those factors? You might be thinking of how many of them, right? Okay, possible factors are 5. Okay, check them, no? Okay, check those factors if they are related to each other, no? Is there a strong relationship? Nakuha? Okay, pansinin nyo yan. Pwede, no? Okay. two at a time. One, this one factor, and this one, and this one, and this one. You check, no? And then you can do actually a correlation coefficient. Okay, you can study those factors. Tapos, kasi dyan, sa mga relationship niyan, you can determine, no? Or which factor talagang impacts, no? Have greater impact on your problem. Nakuha? Okay, ganun po yan. Okay, let's go now here. Okay, so we're near. So we go now in the further tests, no? Okay. So you know now how to actually compute coefficient correlation, no? Coefficient correlation or correlation coefficient. Okay, meron na tayo niyan, no? Carl Pearson. Meron na naman si Carl Pearson. Okay? Ano kaya yon? Okay. So, yun yung tinatawag niyang hypothesis testing. Okay? Meron akong shinare. So, tignan natin to. Stop sharing muna ako. Okay. Let's go this one, no? Let's go to this one. It's your last. But I actually have a lot of examples there, or two, no? To be specific, two examples for us to understand the hypothesis testing now, no? In correlation. Okay, in hypothesis testing correlation, it is further, no? It is further tested if two variables, kikita ba ako? If two variables n, x, y really have a strong relationship, but this time, no? This time, it is what we call the hypothesis testing, and we make use of the t-test. Nakuha? Okay. Dati, z-score. Parang z-score test. Okay. Ito naman is t-test. Okay. So, meron tayong mga table-table din dito. Did you get that? So, further, this is but a continuation of your correlation. How strong that is, no? Okay, let's go. Makinig ng mabuti, no? Hold. Okay, I need to have the tab. If you want to actually, sorry, if you want to actually watch this on your own, you can have this, right? Okay.
Researching follows the scientific method. One of the method is making hypotheses and testing it. Statistical hypothesis is an assumption about what you are testing. The two types of hypotheses are null hypothesis and alternative hypothesis. The null hypothesis, H0, states that there is no significant difference between two measured variables. Alternative hypothesis states that there is a significant difference between two measured variables. There are 5 steps in hypothesis testing. 1. State the hypotheses. 2. Find the critical value. 3. Compute the test value. 4. Make the decision. 5. Summarize the result. Show me an example. Sure. But let us use rho instead of r, and assume that the data are gathered from the whole population in writing the hypotheses. Suppose a teacher studies the relationship of the grades of his students in statistics and the time they spent in tutorial classes. The null hypothesis states that there is no significant relationship between the time spent in tutorial classes and grades in statistics. H0, rho equals 0. The alternative hypothesis states that there is a significant relationship between the time spent in tutorial classes and grades in statistics. H1, rho is not equal to 0. Usually the level.
Okay, sige. Okay, tingnan ko kung wala ng echo. Okay, sige. May feedback po kasi, no? I want to actually speak in between, but we have to finish it. Sige.
Level of significance alpha is given to determine the critical values. Use alpha equals 0.05 and the degrees of freedom is n-2. In our example the df is equal to 8. Most hypotheses involving correlation are two-tailed, meaning the critical values can either be negative or positive. There are several tests used to determine the significance of the correlation coefficient. One of these is the t-test. T equals r, times square root of n-2, all over 1 minus r squared. With degrees of freedom equal to n-2. The correlation coefficient of the variables is 0.68. Substitute the values to the formula. T equals 0.68, times square root of 10 minus 2, all over 1 minus 0.68 squared, equals approximately 2.62. Reject the null hypothesis because the test value is inside the critical region. There is a significant relationship between the grades of students in statistics and the time they spent in tutorial classes.
Okay. May naintindihan po ba? Wala. Okay, tingnan natin. May naintindihan po ba? Sabi ni Aliyah, wala talagang maintindihan, no? Okay, sige. Balik tayo. Babalik tayo diyan mamaya, no? Okay, kasi wala akong naisulat. Okay, so pwede hindi ko naisulat yan sa Excel or what, in our Blackboard. You see, no? You've noticed that my Blackboard is the Excel using the green color. Okay, so balik tayo doon, no? So therefore, meron tayong tinatawag na HO hypothesis. It is the null hypothesis and it's alternative hypothesis. Did you get that? Okay, yung HO, meaning ibig sabihin noon, meron kang hypothesis, pero usually ang hypothesis mo, na sinasabing mo, yung dalawang variables ay wala silang significant relation. Sorry, pagalit ko pa dito, yung pala si Yang. Okay, so we're talking about correlation, okay? X and Y. Relationship between two variables X and Y. Now, there is that test, no? That is the hypothesis testing. Okay, ang mangyayari dyan, magsisolve tayo ng T, no? Meron dyan formula, yung T dyan. Hindi ko na lang muna i-review sa inyo. Hindi ako nakagawa. Okay? Bakit natin kailangan yon? To further, no? To further support, okay? How strong the relationship between these two variables. Ako ha? Okay. Kaya lang, marami tayong compute. So, yung t-test. So, kailangan natin ng correlation. We need to have to compute, no? From that table, see the two columns, no? Okay, time and of course, the result of the exam. Meron tayong coefficient correlation. Okay, tapos, meron tayong sinasabing alpha, no? Alpha, values of the alpha. Nasa table yon. Ito yung values of the alpha. Pakita ko sa inyo, values of the alpha. Okay. So yung values of the alpha, makikita nyo dito. Ito yan, no? Dito. Okay? Ayan. It is either one tail or two tails. So titingin ka lang dito, no? So dito. Usually, ang ginagamit na value ng alpha ay 0.05, no? 0.05. Yan. 0.05 or 2 tails. 0.05. Okay, kung napansin nyo doon, merong 0.05. And then, meron tayong tinatawag na difference of freedom. Ito yon. Okay? Ang difference of freedom usually is computed n minus 2. So for that case, I think it's the n there. The population number it's 10. And then, minus 2, it will be 8. So nandito yan, no? Mamayahan natin yan ulit, no? So ito siya. 0.05 and then 2.306. Like we are actually standardizing it. Naalala nyo yung pag-standardize natin ng score, no? Okay, para tayo nag-standardize ulit. Using t-test, before it's z-score, no? Meron tayong score. O, tapos hanapan natin siya ng z-score. Bakit natin siya nahanapan nun? Kasi nga, we'd like to actually picture it in a curve again, no? The normal curve. Nakuha? Okay, dati may score. Kinompute natin ang z-score niya. Okay, paano natin na-compute? Ako, di ba? Baka hindi nyo na alam. Baka ako, memorize ko pa kayo. Hindi na, no? Okay, the score itself minus the mean over the standard deviation. Diyos ko po, baka hindi nyo na alam kaagad yung z-score. Ito naman may t-test. Bakit natin kailangan? Kasi mapipicture na naman natin siya sa curve. No? Okay, nakuha? Okay, sige. Mas maintindihan niyo itong lecture ni Irish professor, no? Let's have this one. Wait lang. Hindi pa ako okay? So after this, you do an assignment, but you do not work alone, no? Go to the groupings again. Okay, yun pa rin, same groupings. Para magliguan na ka lang kayo doon. Malay mo, humanga yung isa sa inyo dyan. Ligawan na lang kayo dahil ang galing-galing niya sa math. Yung naisip ko no? Kung paano kayo magkaroon ng interest sa math. Parang wala talaga, no? Okay, sige, hold on lang. Stop presenting. Nakataba ako. Okay. Saan na ba si Sir Romen? Ito na, di ba? Okay, hold on. Okay.
Hi guys, this is Jonathan Lambert with the Mathematics Development Support Service at the National College of Ireland. And this short video is going to detail how to test the significance of a correlation coefficient. And for this particular video, we're going to use a fictitious data set. Okay, we have the data set is defined
here. Okay, we have our x variable values.
Ulitin ko,
we have our y variable values.
Pala yung mic ko.
And maybe just to give this a name, let's say over a particular period of time, Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video is going to detail how to test the significance of a correlation coefficient. And for this particular video, we're going to use a fictitious data set. Okay, we have the data set is defined over here. Okay, we have our x variable values down the first column. We have our y variable values down the second column. And maybe just to give this a name, let's say over a particular period of time, for a particular organization or business, we monitored how many sales of a particular product that they achieved on particular days. And let's say we also monitored on them particular days what profit they made. And I suppose the question that we really have here is, is there a relationship between the amount of sales and profit? Or more importantly, is there an association between sales and profit? Or is there a correlation between sales and profit? In this particular instance here, sales will be defined to be our independent variable. So that's our independent variable. And profit will be our dependent variable. Okay, so what we are hypothesizing is that profit is dependent on sales. Okay, and that's why we've labeled these variables as x for our independent variable and y for our dependent variable. Okay,
So I suppose the first part of conducting a significance test of a correlation coefficient is that we need to have the correlation coefficient in the first place. So let's just assume, I'm not going to do the calculation. In one of the previous calculations, in one of the previous videos, there is a calculation that shows you how to, there's a video that shows you how to calculate the correlation coefficient between two variables. And we know that the formula for that is that the correlation coefficient, the sample correlation coefficient, R, is equal to n times sigma xy minus sigma x times sigma y divided by n times sigma x squared minus sigma x all to be squared, and that needs to be multiplied by n times sigma y squared minus sigma y all to be squared, and it's the square root of this particular value here, so it's the square root of this value. Okay, that's divided into the numerator. So to calculate this particular correlation coefficient, we need to calculate the sum of the xy column. We create an xy column in our table, the x values times the y values. We need to calculate the sum of the x column, the sum of the y column. We need to create x squared values, we need to create y squared values, and we need to calculate their respective sums. Now I've done this particular calculation previously, and what I know is that from this particular data set that the correlation, that the sample correlation coefficient comes out to be approximately 0.94. So it's approximately 0.94. What's important to know here is that this particular piece of evidence, this sample data, has been drawn from a particular population, and that population would also have a real correlation coefficient associated with it. So the R value that we've calculated here, the correlation coefficient, this R value is actually the sample correlation coefficient. Okay, so let's keep that in mind. Okay, this is the correlation between our sample data, our sample independent variable, and our dependent variable. Now, there is a true correlation coefficient known as rho. Okay, this is, I suppose, rho. Okay, which is the correlation coefficient for the population. Okay, so the correlation coefficient for the population. Okay? And what we'd like to try to test is we'd like to try to test that based on the evidence that we've captured and the sample correlation coefficient that we've calculated, is there evidence to support that this particular correlation coefficient is representative of the population that it has been drawn from? And to do that, we undertake a significance test of the, I suppose, with respect to the significance of the correlation coefficient that we've observed. Like all significance tests, or like all hypothesis tests, it's a 5-step process. The first step, we define our hypothesis. The hypothesis is a statement about the population parameter. So the hypothesis is a statement about the value that we think that the correlation coefficient of the population has. So it has a null position, H0, and it has an alternative position, HA. And it's a statement about the population parameter. The null position is typically, in this case where we're taking the standard, we're doing a standard test, the null position is that the population coefficient rho is actually equal to 0. Okay? And the alternative position is that rho, the population correlation coefficient, is not equal to 0. So once again, this is a two-tailed test. Okay? So this is a two-tailed test. So for us to show that the null hypothesis is actually incorrect, okay, what we will do is we generate a sample from our population, we calculate the sample characteristics, the sample correlation coefficient, and the question that we have is this particular correlation coefficient far enough away from 0 for it to be significant, statistically significant? Okay. So once we've defined our hypothesis, the next step is to define the significance of our test, our significance. And for all of our tests, we've just chosen a significance value of alpha is equal to 0.05. Okay. Just keep in mind it's a two-tailed test. Okay. So this alpha is going to be split across two tails, the left tail and the right tail. Okay. So once we have our significance chosen, the next step is to construct our test statistic. And our test statistic is defined to be, I suppose, it's a t-statistic, and its t is equal to r minus rho divided by 1 minus r squared over n minus 2, and it's the square root of that value there. Okay. An alternative form of it would be t is equal to r times the square root of n minus 2 all over the square root of 1 minus r squared. This formula here is the general form. This formula here is a specific form where we assume that the null hypothesis is a statement, and the statement of the null hypothesis is that is a specific form where we assume that the null hypothesis is a statement, and the statement of the null hypothesis is that 4 times the square root of n minus 2 all over the square root of 1 minus r squared.
Okay, so there's part 2 of it, no? Okay, screenshot po. Mag-screenshot kayo, no? Okay, para naiintindihan niyo. Okay, mag-i-screenshot din ako. Okay, so for this one, not to further discuss it, no, it's not just enough that we have a coefficient correlation or correlation coefficient that is 0.94. That is the value, no? So for him, consider this is a rho, no? Coefficient correlation or correlation coefficient. It's 0.94. Now, if you notice, no, the value of p is taken there. P, no? And it equals 0 and is not equal to 0. These two will be tested, no? This hypothesis actually, hypothesis, huh? Hypothesis. What will be those hypotheses? Okay, first, the null hypothesis. Okay, the null hypothesis is saying there is no significance relationship. No, there is no significance relationship between the two, the sales and the profit. And then that test that we are going to be actually conducting, this one, no, this will give us a range of score. Okay, we are awaiting for the range of the score of this test that is near 0 and near its range. After it's between its range, including 0, of course, no? Yan siya. Okay? No significance yun. Pero kung ito, ang test na to ay nakuha sa kanya, it's beyond, no? That range, it's two tails, no? It's greater than, sa kabila, it's positive or negative. Sa kabilang negative, wala dun sa range, no? Ng null. Pag ito ang nakuha ng test na yan, ibig sabihin, you do not accept the null. And it's saying that you accept the alternative. And by the way, the alternative is just the opposite of the null, saying there is significance, no? There is a big, meron siyang sinasabing 0.5 or 0.05, it's 5% significance, no? Between sales and profit. Ayan siya. Tignan natin, no? Ang continuation. Just sabi ni Sir. Take note of this one, no? Nandito na tayo. Sa Genyo nyo, ito yung ginamit. Drop natin ito, no? So ito po yung gagamitin ng Genyo. Tingnan natin kung ano ang magiging result ng T rito, no? Okay, let's go. Saan si Sir?
Null hypothesis is a statement, and the statement of null hypothesis is that the population correlation coefficient is equal to 0. Okay. But what we can actually do is we can hypothesize